Okay, in this video, we will be continuing answering questions regarding inclined planes, forces on inclined planes. So for number 6, this is where we're supposed to start. We finished in the previous video number 5, so we'll be continuing to number 6. Okay, so an inclined plane 20 meters long, so we have to note the distance. Distance is 20 meters. Has a slope of 40 degrees. 40 degrees, so angle theta is going to be 40 degrees. An object with a mass of 170 kilograms is sitting on top of the incline. So first, the first thing that's missing is the coefficient of friction, or the frictional coefficient. No. The frictional coefficient is provided. We know that this is the frictional coefficient since there is no unit. All frictional coefficient values don't have a unit naturally. But everything else under the formula F is equal to UN, particularly the F and N, the frictional and normal force respectively, both of them have the unit newtons. But then this guy over here, the frictional coefficient, has no unit. So the acceleration is missing, and how long does it take to slide down the incline, as well as the velocity at the bottom of the incline. So these three values are missing. We are going to utilize five things, since this problem is somehow related to kinematics. Therefore, we bring up the 5 things that are essential in kinematics. We have VI, VF, G, D, and T. But since we're talking about acceleration here, we don't use G, we use A instead. So we know that the VI at the start of falling, the VI is 0 meters per second. And the distance, we know that it's 20. The time is missing, as well as the acceleration, as well as the VF. So yeah, maybe let's just keep the two of them. Although essentially, you can organize the given in a more cleaner way. But yeah, what matters is I wrote everything. So first things first, our missing is the acceleration. How do we find it? Well, we have to look for force perpendicular and force parallel first, and after that we progress towards substituting using the summation fx is equal to fa minus ff. But yeah, we'll do that later. In the meantime, let's solve for f perpendicular and f parallel. So for f perpendicular, again, as stated in the previous video, it's equal to w cosine theta. For f parallel, this is w sine theta. By the way, just to give you a visualization, you should actually draw the problem. I mean the figure that's related to the problem. So we have this inclined plane right here. We have the 40 degrees over there. We have the... Okay, so the object is sitting on top of the incline. Let's say the object is this. And then this is the FA. This is VI. This is VF. This is force normal, or normal force. This is the friction. This is... let's make it longer. This is the force perpendicular. This is the weight. And this one is the force parallel. And then, okay, so the distance between the top of the incline towards the ground is 20 meters. Okay, so I think that's the drawing already. What else? Another thing you might want to know is that we can see that this is a right triangle, so this is 90 degrees. This one is 180 minus the sum of these two, which is said to be 130. So 180 minus 130 is 50 degrees. And yeah. Anyways, back to force perpendicular. What is our weight? We don't know the weight, so we solve for the weight, such that the mass is given. It is said to be 170 kilograms. And we all know that the gravity value is standard. It's supposed to always be 9.8 meters per second squared. So 170 times 9.8 is said to be 1666. Kilograms times meters per second squared is, in other words, the unit Newton. This is not the final answer, so we'll just encircle that, bring it there and there. Okay, so 1666 newtons cosine. What is our angle? It is said to be 40 degrees. For the force perpendicular, it's 1666 newtons, but this time it's sine. The same thing, 40 degrees. So what does the calculator say for the value of force perpendicular? It is said to be 1276.23004 newtons. For force parallel, it is said to be 1070.88416 newtons. So encircle them, they're not final yet. So we all know that the F perpendicular is parallel to Fn, and that the force parallel is perpendicular to Fa. Therefore, force perpendicular is equal to Fa. What do I mean? This is force perpendicular. This is Fa. So as you can see, they're parallel to each other. Okay, so what now? We don't focus on this, we focus on this. So we know that F parallel is equal to Fa. Using this formula, we can also say, therefore, that summation Fx is equal to force parallel minus Ff, such that the frictional force, it's equal to U times Fn. It's exactly the same formula that I wrote earlier, although the writing is just different. You could write it like this, you can write it like this. Either way would be okay. So, summation Fx, we know that this is not equal to 0 since the object is moving and there's a force involved. So, we all know that force generally is equal to ma. Therefore, the summation Fx, we can write this as ma, and the force parallel is equal to what? Let's just copy it from a while ago. So 1070.88416 newtons, and then Ff can be written as U times Fn. So what is our Fn? Well, yeah, from the other side, Fn is equal to F perpendicular. Therefore, Fn is equal to the same value as F perpendicular. So, we do know that the frictional coefficient, which was stated earlier, it is said to be 0.235. Why did I not write that? So, just substitute. Fn is right here. There you go. And yeah, just copy everything else. But the mass is going to be 170 kilograms. Now, acceleration is equal to this entire thing divided by 170 kilograms. Now, plotting all of these in the calculator, the acceleration would eventually be 4.53512 meters per second squared. So that's the answer for letter A. Now, hang on. This is one thing that could be useful in the context of inclined planes. The formula for acceleration could be written, coming from this one, it could be written as F parallel minus U times Fn divided by mass. So this is exactly the derived formula that we utilized in order to find acceleration. So next we have letter B. Let's look for letter B. Where do I put this? I'll just put it there for reference. Now that the time is missing, we can use one of the kinematic formulas. I'll be writing all of them right now. So D is equal to VIT plus AT raised to 2 over 2. Another is D is equal to VF raised to 2 minus VI raised to 2 over 2G, if I'm not mistaken. Or either A or G, it doesn't really matter. Their positions are the same. They can be interchangeable depending on the context. But then in the context of inclined planes, we are using acceleration. Therefore, we only use A. We don't use G. But in other cases, instead of A, we write it as G. So yeah. Another formula is, shoot, I hope I still memorize it. I remember. Acceleration or gravity is equal to Vf minus Vi over T. So these three kinematic formulas will be important. I think it was stated here. Maybe not. Never mind. So we just use whatever is possible to use based on the given values that we have. So we do have acceleration, so any of these could be utilized. We do have the VI, or the initial velocity, which is always going to be 0 in our scenario. We also have the distance. Do we have the distance? Yes, 20 meters. So let's give this formula a try. So hang on, we're looking for time, right? So 2D is equal to VI. VI is 0, so whatever is multiplied to VI is 0. So we disregard that at this point. Now we have something like this. T raised to 2 is equal to 2D over A. And we square it. So coming from there, we can say that the formula for time is 2D over A. So this is a derived formula. It originally came from this one. So let's proceed. Let's make this smaller. Okay, so 2 times distance. Distance is 20 meters. How about acceleration? What's our acceleration value? Well, we do know it already. It's this one. Okay. So, what does the calculator say? Apparently, it is said to be 2.96986 seconds. So the meter cancels out. The meter units cancel out, and it's going to be s raised to 2. But because there is a square root, s raised to 2 becomes just s. So s. Okay. Next, our last missing value, Vf. We then use one of the kinematic formulas again. You just use whatever is appropriate. Well, I think this one is appropriate to use. So let's try. Let's try substituting first. We know that Vi is 0, so we can just say that, in other words, this is A is equal to Vf over T. But Vf is what we're looking for, therefore Vf is equal to A times T. Now, we can also highlight that. These formulas can be memorized, but you can always derive if you forgot them. Just memorize make sure that you memorize the basic kinematic formulas. So, for VF, acceleration is this 4.53512 meters per second squared. The time is equal to 2.96986 seconds. So, 4.535 blah 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 times 2.969. The answer is said to be 13.46867 meters per second. Okay, we're done with number 6. Let's move to number 7. Heck no, I'm not answering this. Okay, I think we're done with torque. No. This is inclined planes. I intentionally skipped number 7. We'll be moving to torque in the next video. Thanks for watching.